7.4, writing equations in two variables. Our essential question is how can you write an equation in two variables? So you're going to learn how to deal with two different variables in one equation and how to solve that. It's very simple compared to what we just did. If you understood 7.2 and 7.3, you should have no issues with this one except for, the thinking process is a little different, but it's really the same principle. So here we go. All right, the 7.4 lesson. So we begin with a couple of key vocabulary, and one of them is an equation in two variables represents two quantities that change in relationship to one another. A solution of an equation in two variables is an ordered pair that makes the equation true. So in example 1, you'll kind of learn what that means, and we're just going to go through one of them to check your understanding for that. Example 1 is identifying solutions of an equation in two variables. The given directions are, they say, tell whether the ordered pair is a solution of the equation. So a key word here is ordered pair. We've already dealt with ordered pair. So if they give you an ordered pair of like 1, 2, remember what represents our x and what represents our y. This is our x, this is our y. So that's what they're talking about. Those are what your variables equal. So I'm going to go over 1 and then look at part B in your book if you need a little extra help. So if these were the directions and they gave you y equals 2x, and then they give you an ordered pair of 3, 6. All you're doing is filling in your x and y value. Remember, this is your x value, this is your y value. And they don't tell you that that's your x and y. That's something that we know about ordered pairs. So all you're doing is you're filling in which one's my x and my y. My y is over here, and here's my y over here. So I'm doing 6 equals, the 2 stays the same, times, what's my x value, which over here tells us it's 3. So now we check that. 6 equals 2 times 3 is 6. So yes, so my answer for this would be 3, 6 is, the ordered pair 3, 6 is a solution. You'll see practice problems and things like that as you work. Alright, here are a couple notes for you before you start example 2. So you can use equations in two variables to represent situations involving two related quantities. So the variable representing the quantity that can change freely is the independent variable. Okay, so that's when the variable can change freely. The other variable is called the dependent variable because its value, I'm going to put this kind of like in a bubbly looking circle, it absolutely depends on the independent variable. So the other variable is called the dependent variable because its value depends on the independent variable. So write that down, I'll kind of explain it as we're going. Example 2, using an equation in two variables. So they give you directions like this. It says the equation y equals 128 minus 8x gives the amount y in fluid ounces of milk remaining in a gallon jug after you pour x cups. Your first step is to identify the dependent and independent variables. Okay, follow with me here. This isn't actually as hard as it seems. So identifying the dependent and independent variables. Let me get my pointer. So because the amount of y, remaining, depends on the number x of cups you pour, y ends up being the dependent variable. It depends on what x is. So again, we are looking right up here. This is what our equation is, 128 minus 8x. X is an independent variable because it can freely change. So in other words, I could say, well, let's pretend x equals 2. So if x actually equaled 2, it would be 128 minus 8 times 2, and that would be what y equals. Because I can change this number, it can change freely, it is the independent variable. Because I can make a variable any number to equal what y would equal, y becomes our dependent variable because it actually depends on what y or what x has to be in order to be correct. This is not something that can change freely. Your y stays the same depending on what our x here equals. So you're going to see questions like identifying what you have, what is my independent variable, what is my dependent variable, and I'll give you another example in a second that will kind of help you. But that's identifying is the number one thing that you have to figure out. Out of the variables that you have, which one's dependent, which one's independent? Y, whoops, okay, so y ends up being our dependent variable because it depends on x and what x equals. So part B can prove to you why the y value is your dependent variable, and it can explain why the y is your independent. So how much milk remains in the jug after you pour 10 cups? Remember, our original equation looked like this, minus 8x. So now we're going to fill in for what we know. The cups is representing x, because that's what it told us up in our original directions. So the x equals cups, and the y equals fluid ounces. So if we have 10 cups, so I'm going to leave my y, get 128, that's all staying the same. And then what changes is our cups. We have 10 cups. So what we would do is we would substitute the x for 10, and then we would solve. So now I have, we would start with order of operations. We do multiplication first. So 8 times 10 is 80. Keep everything else the same. Just drop it down. We haven't solved anything else. And then you can subtract your 128 minus 80, which should give you 48. So again, depending on what x equals, my amount of cups can change. This can change, so that makes it, it freely changes, so it's independent. It can freely change. Your y is dependent on what can change, so it means it's our dependent variable. So let's practice with this one. The equation y equals 10x plus 25 gives the amount y in dollars in your savings account after x weeks. So if I said identify the independent and dependent variables, you have to say to yourself which one freely changes, which one has to be the same, no matter what. So looking at y equals 10x plus 25, which one could change? Okay, so we're talking about x weeks. Well, we don't know how many weeks. That can change. It could be 2 weeks, it could be 3 weeks, it could be 4, etc., etc. Whatever amount x equals, okay, your y depends on that. So x value, weeks, is your independent variable. Where y, the y value, which is money, your dollars, depends on how many weeks you're talking. So that becomes your dependent variable. Alright, I'm going to complete the rest of it in class so I can go over that more clearly with you. Your practice problems are from Big Green, page 319, numbers 9, 11, 13, and 15. Please don't forget the answers are in the back of the book so you can check your answers to see if you're correct. For numbers 9 and 11, you're going to tell whether the ordered pair is a solution of the equation. Remember, if you have an ordered pair, the first number is your x value, the second number is your y value. That answer would be a yes, no answer for numbers 9 and 11. 13 and 15, we're talking about independent, and dependent. variables. So the directions, sorry, I have sloppy writing, you don't have to write all this. My directions say identify the independent and dependent variables. So think about that. Use your notes. Go back, reread. What did you come up with? You're going to either have like a number 13. It's asking for A and W. Which one's your independent? Which one's your dependent? 15. It's a T and a P. So decide which one it is and tell me why. Well, at least be able to discuss why. You don't need to write it down. All right. See you in class.